the datagram approach to packet switching. So switching in the network layer in the internet is done using the datagram approach. So communication at the network layer in the internet is connectionless. So two things you have to note down: the communication in the network layer, communication in the network layer in the internet is connectionless, and switching at the network layer in the internet is done using the datagram approach to packet switching. Now the addressing is very much important. You know, the internet address, classful addressing, subnetting, supernetting, and classless addressing, and dynamic address configuration, and network address translation. So an IP address, we know that we are in IPv4. So IPv4 address is a 32-bit address, and the IP address are unique and universal. The IP address is always unique and universal. So suppose this is a IP address, so it is done by the dotted decimal notation. So it is, as it is a 32-bit, so here it is divided into four groups, 4 bytes actually. There is a 8 bits. So here the here is the 8 bit. So 8 bit, here the 8 bits are represented in the decimal form. It's the decimal form of the 11000. The decimal form is 128. Here is the 1011, the 11, the 113, and this is 31. So it is the decimal, dotted decimal notation for the IP address. So now the binary, decimal, and hexadecimal number system are reviewed. Reviewed in appendix B is not required. Now suppose we are giving some example, some example and solution. Let's change the IP following IP address from binary notation to dotted decimal notation. You know very well there is a 32-bit address, and we have to make it dotted. We have to convert the decimal into for every 8 bit. So it is a 129, it is 11, it is 11, it is 239, like that. The B also, it is a 249, it is 155, it is 251, and it is 50. Same things. So decimal, from decimal, dotted decimal notation to binary notation, very easy things. You can able to do it. Now we know the classful addressing. The classful addressing, there are the address space is divided into 5 classes: A, B, C, D, E. A, B, C, D, E. The 5 classes addresses: class A, class B, class C, class D, and class E. Now this is a class A. So how we can know it is a class A address? The class A address always start with 0. The first bit of the class A address is always 0. Now for class B, here the first two bit of the class B is always 10. Now for class C, the first 3 bit is always 110. Now for the class 4, the first 4 bit is 1110, and for the class E, the first 4 bit is 1111. So here the classification of the IP addresses like that way. There are the 5 addresses: class A, class B, class C, class D, class E. So here the class A is started with the 0. The first bit of the class A is always 0. For class B, the first 2 bit is always 1 and 0. For class C, the first 3 bit is always 110. For first 4 bit, the class 4, for class D it is a 1110, and for class E it is 1111. Now this is one of the algorithm for getting the finding the address class. Start is a first bit is 0, then class A. If it is 1, go to the next bit. It is either second bit. What is the second bit? 0. So it is a class B. Now check for the third bit. It is 0. It is a class C. And check the fourth bit. It is 0. It is a class D. If it is 1, it is a class C. This is one of the algorithm for finding the address class. So here the class, we can, this is some example of finding the class of the each address. So here the A is starting address is 0, that is a class A. The first 4 bit is 1. For B, in number B, so it is always class E. So this is the class decimal notation. Class A is always, first byte is always 0 to 127, as it is the first bit is 0. So, it means the other 7 bits may be 1. So the value is 127. For class B, it is start with 128 to 191. For class C, it is 192 to 223. For class D, 224 to 239. And for class E, it is 240 to 55. So by seeing this decimal notation, we can also classify the addresses. So here the for A, it is the 227. Here the address is 227. So the first byte is 227. So it is between 224 to 239. So here is the class D address. As it is a first, for B, it is the first 8 bit or first decimal notation is 252. So as it is between 240 to 255, so the class is E. And for the C, it is the 134. So here it is a 128 to 191. So it is a class B. Now the net ID and host ID. So as it is a 4-byte address, every address is a 4-byte address. So these bytes will be divided for the for net ID, network identification, or another is for the host identification. So for class A, the byte 1 is used for the network identification, the net ID. And for class and others, for byte 2, byte 3, and byte 4, it is a host identification. So here the address, suppose that this is there will be some address. So this the first byte address will be the address of the network, and these 3-byte address. So this 3-byte address will be the identification of the host. And for class B, these two addresses, byte 1 and byte 2, these two addresses, byte 1 to byte 2, this is for the network address, and other 2 byte is for the host address. So, and for class C also, it is a byte, first byte, second byte, and third byte is for the network identification, network ID, and byte 4 is for the host identification, host ID. So suppose for which type of organization we can use the class A, where the number of host is maximum.
Sir, you're not audible.
Sir, your mic is muted.
So for our class A, what the class A will be used? Class A will be used for the organization where the number of hosts is maximum. As we know, we are seeing that byte 2, byte 3, and byte 4, the rest 3 bytes will be used for host address. So as the host, we get a large address space for the host, we get a large number of address range for the host. So when the organization will be very high, when the large in an organization when the number of computers, when the number of networking devices will be high, then we will use the host ID. And for the class B, is a same bytes are taken, same number of bytes are taken for the network ID and as well as host ID. So for the middle class of organization where the host ID is middle number of computers are needed to connect with the network, then we can use the class B, as it is the first 2 byte used for the network address, and the last 2 bytes, byte 3 and byte 4 will be used for the host address. And for the class C is a network ID is maximum, byte 1, byte 2, byte 3. With these 3 bytes will be used for the network identification, and only the byte 4 will be used for the host identification. So but the number of host is very less, so then the class C will be used, and class D is used only for the multicasting addressing, and class E will be used for reserved for future use. Class E is already reserved for future use. Class E will be used for the reserve for future use. So suppose the blocks in a class A, how we are giving some example. So suppose these are the net IDs. So these are the class A addressing mode. So this is the net ID. Suppose here the net ID is 0. So 0 means it will be 0002, 0 to 255, 255, 255. So if the net ID will be 73, so the host ID ranges, the host address ranges will be 730002, 73 and for the net ID 127, the address range will be 127.0.0.0.2, 127.255, 255, 255. So these are the address range. So the first byte for the class A, we know the first byte will be used for network address, a network ID, network identification. The rest 3 bytes will be used for host ID. So here we are giving example of class A. Here we are giving one example of class A. So here suppose in here the net ID is 0, the address range will be 0.0.0.0.0 and host address will be the 0.255.255.255 for the net ID. Here the net ID is 73, so where the host address will be start from 73.0.0.0.0 like that way it is going on. So 73 is here we are emphasizing that here we have this net ID 73. So here the host, so host will be start from like that 73 0.0.0.1, it will start from there and ultimately 73 to 55 to 55 to 254 and 73 to 55 to 55 is a special address and the network address will be the 730. Generally the first address will be specified for the network address. So here the 73.0.0.0 will be specified for the network address. So it and 73.0.0.1 will be 73 255 255 254 will be used for our host address. So millions of class A addresses are wasted. Why it is wasted? We know there is a huge address range for the host in case of class A. So millions.
You are not audible.
So millions of the host address are changed. Millions of the host address are wasted. Now we are giving an example of class B. We are giving an example of class B. So here the network, suppose the network address is first is 128. So 128 the network, so the address will be range of 128.0.0.2, 128.0.255.255. It may be, or network address may be 120.8. So here the 120.8.0.0. So here the network address 128.8.255.255. So here as the first 2 byte will be used for the network ID. So here the first 2 byte, here 128, here the network ID is 128.0, here the network ID is 128.8, here the net ID is 191.255. So here the host address will be the last 2 byte. So here the address range for the host will be 128.0.0 to 0.2 up to 128.0.255.255 like that way. Now we are emphasizing that network. So here the first address 128.8.0.0 will be the network address and 128.8.255.255 is a special address. So other addresses 128.8.0.1 up to 128.8.255.254 will be used for host addresses. So many of the class B addresses are also wasted. Many of the class A addresses will be also wasted. Thus, the number of addresses in class C is smaller than the needs of the most organization. So, if you go to the class C, here the address range is address range for the host is very less. So here for class C, it may happen that the need of the organization, the address range available for it will be the address level available will be lesser than the organization wants it or the organization need it. It may happen. So for class A, most of the addresses are wasted. For class B, for class B, the media, the half of the wasted, or the many of the addresses are wasted. Or for class C, the class A addresses are the smaller than the need of the most of the organization. So class C must many times the class C must not able to fulfill the need of the address need of the organization. So now, this is an example of the blocks in class C. So here we know the three addresses, first 3 bytes. So first 3 byte is will be specified for the class C. 198.0.0 is the it will the network address. So suppose another 200.11.8 is a network address. So here the 223 to 255 to 255 is a network address. So here the host address range is very less, 0 to 255, yeah, 0 to 255, 0 to 255. So ultimately, what is happening? So when we are emphasizing that 200.11.8, so what we are getting, the 200.11.8.1, the starting address will be that starting address of the host will be that, and it will be ended with .254, where the network address will be 200.11.8.0, and it is a special address 200.11.8.255. So here only 1 to 254, only 1 to 254. That means only 254 hosts will be able to connect by the class C address. So it may be the very less number for a large organization. Now one of the example of the class A, class B, and class C for both. So so here this is an example. Suppose this is a network ID for class A. So this will be the host IDs. So for class B, suppose this is the network ID. So this is the host IDs. Suppose class C is a network ID. So these are the host IDs. So this is an example of for these three: class A, class B, and class C. So in classful addressing, the network address is one that is assigned to the organization. So network in classful addressing, the network address is the one that is assigned to the organization. So in an organization, suppose our BC Engineering College is an organization, and it is having thousands of machines. So one network address will be assigned for an organization. So one organization will be one network address. So, this is a given. This is a finding of network addresses. So suppose this is a class A address to 23.56.7.91. How will get the network address? We know the first byte is a network address. So 23 is will be the starting first byte of the network address. So 23.0.0.0 will be the network address. So as it is a class A address, the first byte is a network ID. So first byte is 23. So the network address will be 23.0.0.0. So this is a given address. So this is as 132.6.17.85. So as it is a class B address, we know the range of class B address. So as it is 132. So it is a class B address. So we know the class B address is the first 2 byte is a network ID. So the first 2 byte is a network ID. So we are getting the first 2 byte is 132.6. So it is a starting network ID. So network ID will be 132.6.0.0. So this is the network address. Now we are getting one of the network address 70.0.0. Find the class. So it's a class A because the net ID is only 1 byte. That's the net ID is a network address 17.0.0.0. So as a network ID is only 1 byte. It is 17. So it is a one. So it is a class A address. So a network address is different from network ID. A network address is different from network ID. A network address has both net ID and host ID with zeros for the host ID. So a network address is different from net ID. We know the network address is mainly the first we are getting the net ID. So a network address has a both net ID and host ID. Uh, it has both net ID and host ID. And what is the network address? For network address, the host ID will be the zero. We will replace all of the host ID with zero. So this will be the network address. So this is the difference between network address and net ID. So network address having both net ID and host ID, but in case of network address, we will make zero for the host ID. So this is the this is a router, this is a network address. Suppose this is a network address 223.3.6.0. This is a network address, and .3.6.0 is a network ID, network address. So here the network address is 134.18.0.0. So it is in class B. So so here it is in class A, that means 124.0.0.0. It is a network address. So it is in class A. So IP address is designed with two levels of hierarchy. Is there two levels? What is the hierarchy? Is a network and host, network ID and host ID. So there are different types of levels of hierarchy, and we are getting. So this is all of from me for today. Thank you all of you.